Hello. Today we will be talking about predictions. And what is a prediction? Prediction is something you can reasonably expect to happen in the future. Example would be that weather forecasters use several different methods of forecasting to make predictions about the weather. One way to make a prediction is to use probability. Okay? So remember, predictions, you've seen it before in language arts, you've seen it in science. You make predictions, you think about what's going to happen in the future. And whether or not it succeeds or fails depends on the information you know, and you make your best judgment. In other scenarios, you use math, okay? Sometimes math can help you predict to understand if something's going to work or going to fail. And we're going to look at some examples. Let's try this. Caitlin finds the experimental probability of her making a 3-point shot is 30%. Out of 500 3-point shots, about how many could she predict she would make? Okay, so 30% shot. Is she going to make it often? No, it's less than 50. If we go back to our first probability assignment, it looks like it's unlikely. So if she shoots, it's not as likely to make it in. But let's see what happens if she shoots 500 times. How many shots do we expect to get in? We know it's not going to be 50%, so it's less than 250. 30%, it's around 25%. So I could take this and almost divide by 4. Remember, I'm taking like a quarter, so like 100 something. But let's actually do the math. And how would we actually figure that out? So, one way we can do it is to set up an equation. So what kind of equation should we do? It says, is 30% out of 500? These words I'm emphasizing, you should kind of remember that of and is, it's like a proportion. And of, whenever we see that word of, it can mean multiplication. And that's what we're doing. We're going to take our percentage, 30%, they turn into a fraction, and multiply by the total number of attempts, shots, it could be roll of dice or so forth. Look here. Multiply the probability by the total number of 3-point shots. And what they did is they got 150. Now they used a fraction, but we had a percent. 30%. Now I know I can't just do 30% times 500. 30 times 500, let's try that out. 30 times 500. 15,000 shots? No, that doesn't make sense. That's right, because remember, we can't do percent multiplication. We have to turn it into a decimal point. We have to convert it. So here's my decimal, and if you remember, to get rid of a percent, you have to move your decimal place 2 places to the left. So I would get 0.30 times 500. And what will we get? 0.3 times 500, 150. That makes a lot more sense. It matches up, and we did the math correct. Okay? And it makes sense. So if you ever see a percentage, always turn it into a decimal. Or if you have a fraction, turn it into a decimal. Remember, multiplying by decimals is usually the easiest. That's what we do in calculators. And generally in real life, you'll see percentages, but we convert it to decimal. If you don't remember how to convert, look into your notebook, and if you remember, we have that foldable that will convert things to decimal places or decimal numbers or fractions or percents. So that's one method. We can take our probability, our percentage, our fraction, or decimal, and multiply it by the total number of shots. This is probably the easiest and the one I will try to focus on. The second method is to set up a proportion. And what does that mean? Proportion. Remember, this is over of equals percent over 100. This could be part as well. Part over whole. Well, it's back again. So this is where they used their numbers. Okay, they had a percentage, but they turned it into a fraction. So they did something a little different, but we can convert it to what we know. Okay, but let's look at what they did. They had a proportion 3/10 equals x over 500. And what did they do? They cross multiplied. So 3 times 500, 10 times x. 3 times 500 is 1,500. 10 times x is 10x. How do I get rid of the 10? Train tracks. And I do the opposite operation. And if you look here, it says the original operation is multiplication. So what is the opposite? That would be division. Look here. We would divide. And if I divide everything by 10, because whatever I do to one side, I do to the other, hey, 150. It works. Now this one might have been a little confusing. They set up proportions because they knew this meant 30 out of 100, and this is blank. But let's try it our old way. So again, 30%. So that would mean I would put the 30 here over 100. Makes sense. Is over of, or part over whole. Let me just write part over whole. Okay. Now, what's my total or whole shots? It would be 500 because I'm trying to figure out of 500 how many is going to be made in. Right? Of. So you can think of that way because this is my total. Right? I cross multiply 100x. Let me show you the cross multiplication this way and this way. We cross multiply, so 100 times x and 500 times 30. 500 times 30. 15,000. Now remember, the operation between is multiplication, so how do I get rid of it? I do the opposite, which is division. I divide, this gets canceled out, and if I divide this, divide by 100, would you look at that? 150. So the book showed two methods of setting up and solving for how many shots. Even though it looks different than we know, all the answers, 150, 150, 150, and 150, are the same. So we can use our old way to solve these prediction problems. Now I'll say it again. Method 1 is generally going to be the easiest. We're setting up an equation. we take our probability and multiply it by the total number of shots. So where else can we use this information in real life? So last time we talked about LeBron James, and how he shot his 3-point shots and his field goal shots. Imagine you create your own perfect team. Well, LeBron James will probably be on it. And one of the best centers is this guy named Andre Drummond. Now, it's the fourth quarter, 30 seconds left. You're behind by 3. Who will you choose to make the shot, a 3-point shot? Will you give it to LeBron James or Andre Drummond? Imagine if you're the coach. So let's look at their stats. If we go over here, here's his 3-point stats. Let's make that a little easier to see. So if LeBron takes a shot, he'll make it around 35% of the time, 33, 36, okay? But let's look at Andre Drummond. If we gave him the ball, oh no, 14.3, 28, 4%, and 13%. So who has the higher probability of making the shot? Clearly, it would be LeBron James. If you're the coach, you look at these numbers, you know I'm not going to give the center, Andre Drummond, the ball because chances are he's never going to make it in. This is a very low percent chance. But if I give it to LeBron, look at his 3-point shots. Yeah, he has a better chance. Is it still very likely he's going to make it in? No. It's less than 50%. But he has a better chance. Okay? We always look at the percentages. We understand the risk, the probability of something working or not working, and we use that math to predict the best result. So again, look at these numbers. You can clearly see that all his numbers are bigger. So he has a higher percentage to make the shot in. So here we have the 2 methods of creating prediction, just like what we went over before. Number 1, we multiply the probability by the total outcomes. So whatever that percent is, we turn it into a decimal. That's the probability. I'm using percent sign. And we multiply it by the total outcomes, the shots, the days, the combinations, or whatever. Okay, the total amount. So we're finding a percent of the total outcomes. The second option is to set a proportion. Remember, after we set it up, we cross multiply and solve for the missing variable. So again, we had part over total or part over whole equals percent over 100. We cross multiply and solve it. You can choose whatever method is most comfortable to you. Either way, as you've seen before, will work. So let's look at this. If you roll a number cube 15 times, how many times do you expect to roll a number less than 6? Okay, I don't see a probability number. I don't see like a fraction or percent or even a decimal. So first thing to figure out is our probability. A number less than 6. So if you have the dice, right? How many sides are there? There's 6 total sides. And how many numbers are less than 6? Well, we have 1, 2, 3, 4, 5. Not 6 though, right? So these are the numbers that are less than 6. So what's my fraction then? To expect a number less than 6. 1, 2, 3, 4, 5. I could choose these 5 numbers out of the total 6. Because I could choose the number 1, 2, 3, 4, or 5. So I have my probability now. Now, what is my total outcomes or total tries? 15. So let's put total here. And we have 15. So again, remember, I'm going to multiply my probability with my total. So I have 5, 6 times 15. Now, if you don't want to really use a calculator, how do I multiply a fraction times a whole number? I can't do fraction times a whole number, but if I turn a whole number into a fraction, I could do fraction times fraction. Just multiply across. But how do I turn this into a fraction? If you remember, to turn a whole number to a fraction, you put it over 1. Because 15 divided by 1 is still 15. Now, how do we multiply two fractions? We multiply across. So 5 times 15, 75. 6 times 1, 6. Looks like we have to use a calculator anyway. 75 divided by 6, 12.5. Another method you could use, because it's a fraction, I could do, remember, this is the same thing as saying 5 divided by 6. The fraction bar means division. So I could do 5 divided by 6 times 15, 12.5. I get the same number. So again, if I do 5 divided by 6 and then times 15, I would still get the same number. Now, what does this number mean? That means let's read the question again. About how many times do you expect to roll a number less than 6? So I expect to roll around 12.5 times. Now, can you roll a half a dice or half a chance? No. This is the mathematic way, but we can round it. We can round up. So you can say maybe 13 out of the 15 tries should be less than 6. It should be a 1, 2, 3, 4, 5. That is roughly the chance to get a number less than 6. Now, will it always be this? Will it always be the number? Will 13 numbers always be between 1 and 5? No. But this is the mathematical probability. If you put it in action, it is very possible that it could come out to be 10 out of 15 tries, 14 out of 15 tries, or something like that. It could even be 1 out of 15. But what's the probability of that? Very, very low. Because we looked at the math and it said, hey, it should come out 13 times, one of these numbers. Okay? It would be almost impossible or improbable for only one of these numbers to pop out when you roll the dice 15 times. So again, we're looking at the probability, the total number of tries or attempts or whatever, and we multiply it. Let's go on to the next one. The experimental probability of hearing thunder on any given day in Florida is 25%. Out of 730 days. How many days can Floridians predict to hear thunder? So I have a percent. What do? Let's multiply the probability by the total outcomes. We have 25, but remember, convert 25% into a decimal. We move our decimal point 2 places over, so 0.25, and we multiply by the total days or total outcomes, 750. If I do that, 0.25 times 750, so roughly 187.5 days you will hear thunder. That's a lot of days of hearing thunder. Must be raining in Florida. Number 2, a player on the school baseball team reaches first base 40% of the time he is at bat. Out of 50 times at bat, how many times will the player reach first base? We got our percentage. We got our total outcome. Convert this to a decimal, 0.40 times 50. And if we do it, we would see 0.4 times 50. 20 times he will make first base. If you flip the coin 18 times, how many times would you expect heads? Oh, no percentage this time. But we know a coin. How many sides are there to a coin? There's 2. And how many are heads? Only 1. So this is my probability. 1 out of 2 sides. Now how many times is he going to flip it? Or the total outcomes? 18. So again, 1/2 times 18. I could convert this to a decimal. So 1 divided by 2, 0.5 times 18 equals 9. So roughly around 9 times, if he flips out of 18, will be heads. Let's try 2 more problems. A bag containing 6 white marbles and 4 black marbles. You pick out a marble, record its color, and put it back in the bag. If you repeat this process 35 times, how many times would you expect to remove a white marble from the bag? So look at our probability. We're looking for white marbles. How many white marbles are there? There's 6. So in the bag, we know there's 6 marbles. But how many total marbles are there? Well, there's 6 white, 4 black. 6 and 4 total. What operation should I choose? Multiplication. Not multiplication, sorry. Adding. 6 plus 4. So there's 10 total marbles. 6 of them are white. And how many times am I going to do this? How many tries? 35. So I take my probability, 6 out of 10, times 35. 6 divided by 10 times 35. So roughly, you expect 21 times to pick out a white marble. Again, this one was a little tricky because it didn't give you the percent. You had to figure out the probability on your own. Look for the key words. White marble. White marble. That's what I'm looking for. That should go on top, just like in the past. Right here, flipping a coin. Heads. Heads, there's only 1 heads out of 2 sides of a coin. Look at number 5. Escobar family is planning a 7-day vacation. Maybe this is important. they would like to go to Boulder, Colorado in December. Based on last December, Boulder had 23 days when it did not snow. 23 days without snow. If the Escobar would like it to snow on at least 3 days, should they go to Boulder? Okay. So, last December, Boulder had 23 days when it did not snow. I have to look at my probability. So, they want it to snow. But how do I figure that out? Well, it says last December. And we're talking about days. How many days are there in December? Well, there's 31. And if it snowed, it did not snow 23 times. How many times did it not snow? Well, I could do 31. That's my total. Minus 23, because this is the non-snow days. And you would get 8. So 8 out of 31 days, it did snow. Oh, that's pretty good. Now, how many days or how many tries do they have? Well, that one's tough. I don't know about tries, but I do see 7 days. They're going to be there for 7 days. So here we have it. 8 snow days out of 31 days. And they're going to be there 7 times. It's a 7-day vacation. So we're going to take this and multiply it. So 8 divided by 31 times 7. So roughly, if they go there for 7 days, only 1.8 days will it snow. Is that good enough? No. They want 3 days. So, should they go to Boulder? No. They wanted snow on 3 days. But if they did the math, they would see, I only get 1.8 days of snow. Okay. So again, the 2 methods of creating predictions. I'm focusing on number 1. If you choose to do number 2, go right ahead. You know how to set it up. So number 1, we multiply the probability by the total outcomes. If it's a percent, a fraction, or decimal, that's the probability. You have to figure that out if it's not given to you. And we multiply it by the total outcomes, whatever it's the shots, the days, the combinations, the tries, the dice rolls. You're looking at the total and you multiply. Number 2, set a proportion. So this will be your your probability. No, this would be your probability, sorry. And this would be your total. This one's a little different, okay? Probability percent, total, your total tries. Then you cross multiply and solve. But again, I think number 1 will be the easiest and most self-explanatory. So try to do number 1 first by multiplying the probability by the total outcomes. If it doesn't work, set up a proportion.